Okay, let's dive into this absolutely incredible story of how we taught machines to think. I mean, it's a tale of forgotten geniuses, of wartime urgency, and a global revolution that really connects every single one of us today. I want you to picture this for a second. It's 1941. You're in the middle of the North Atlantic, freezing black waves all around. Allied ships are just pushing through the darkness, and they have no idea, absolutely no idea, that German U-boats are lying in wait just beneath them. And then, suddenly, torpedoes. Explosions just tear through the night. It feels completely hopeless. But hundreds of miles away, a totally different kind of battle is being fought. Over at Bletchley Park, a man named Alan Turing is feeding this punch tape into a mechanical monster called the Bombay. It just clatters to life, and after whirring through trillions of possible combinations, it stops, just halts. The code is broken. Suddenly, the U-boat's positions are revealed, ships can change course, and lives are saved. All thanks to a machine. Now, here's the thing. Turing's incredible victory, it wasn't the beginning of this story, not even close. It was actually the culmination of a dream that's thousands of years old. You know, this whole quest to mechanize logic, it started way back in antiquity with tools as simple as the abacus, but it reached a stunning peak with devices like the Antikythera mechanism. I mean, this was a 2,000-year-old clockwork made of bronze gears, found in a shipwreck that could predict eclipses. This wasn't magic, folks. This was ancient computation. So this ancient dream, right, this idea of turning logic into a machine, it was a powerful one. And after lying dormant for centuries, it was about to be reborn in, of all places, Victorian London. And yeah, that ancient dream, it was resurrected by two absolutely incredible minds. You have Charles Babbage, who we can call the architect. He designed the analytical engine, basically the first real blueprint for a general-purpose computer. But then you have Ada Lovelace, the prophet. She's the one who saw its true soul. Get this, she wrote the very first algorithm for a machine that hadn't even been built yet. It didn't exist. And this quote right here, it just perfectly illustrates her genius. Lovelace had this incredible realization. If a machine could manipulate numbers, and numbers are just symbols, right? Then it could manipulate any symbol. She imagined computers composing music, creating art, more than a century before it actually happened. I mean, what a profound leap of imagination. So, fast forward, the urgency of World War II, it literally dragged these forgotten Victorian dreams off the page and into reality. Suddenly, the abstract ideas of Babbage and Lovelace weren't just theories anymore. They were about to become weapons, brought back to life by the desperate need to calculate, to decipher, and ultimately to win. Over in the US, ENIAC was born, and this thing was a monster, a massive electronic brain made of wires and vacuum tubes. But the real heroes, often uncredited, were 6 brilliant women, the ENIAC 6. They programmed it, but not with code as we know it. They used diagrams, switches, and just pure logic. Meanwhile, back in the UK, Turing's team built Colossus to crack the toughest Nazi ciphers. Programming was happening, even if it didn't really have a name yet. Okay, so the next really crucial breakthrough came from John von Neumann. He had this idea: what if a computer's instructions and its data could live together in the same memory? It sounds simple, right? But it was absolutely revolutionary. It's what made machines truly universal tools. Flexible, reprogrammable, and this architecture, it's still used in pretty much every device you own today. Your phone, your laptop, all of it. All right, so the hardware is established. We have these incredible machines. But the next great challenge was, making them usable. How do you tell these electronic brains what to do without spending weeks just plugging and unplugging wires? Well, the answer was software. And let me tell you, early programming was painful. It looked exactly like this, just long, maddening strings of ones and zeros. Imagine typing all that out, and a single mistake, one wrong bit, and your whole program, maybe weeks of work, would just fail. There had to be a better way. And thankfully, that better way came from an absolute visionary, a Navy officer named Grace Hopper. She invented something called the compiler. The best way to think about it is like a universal translator. It let programmers write in human-friendly, English-like words, and the compiler would do the hard work of translating it into the ones and zeros the machine could actually understand. A total game changer. Hopper's vision was just revolutionary. She pushed for languages like COBOL to bring programming out of the labs and into the business world. She argued for something called machine independence, this radical idea that your software should be able to outlive whatever piece of hardware it was running on. And, oh yeah, The fun fact, she literally found the first computer bug. It was an actual moth stuck in a relay. So as software started to grow up, you get these two powerful philosophies emerging. It's kind of like two different tribes. Over at Bell Labs, you had the pragmatists. They were creating these elegant, powerful, no-nonsense tools, like the Unix operating system and the C programming language. But then over at MIT, you had the idealist, Richard Stallman. He argued that software should be free, and he meant free as in freedom, not just free of cost. He was laying the ethical foundation for what would become the entire open source movement. Okay, so next up, we're going to see how all of these different threads, the hardware, the software, the philosophies, they all start to come together. Because the rise of personal computers and networks, this is what took programming out of the big corporate labs and put it into our homes, into garages, and yeah, eventually, right into everyone's pocket. Really, the modern world we live in was built when four totally separate innovations finally came together. It's like the perfect recipe. First, you get the tiny silicon chips that make computers cheap enough for you and me. Then, you get Ethernet, which allowed them all to talk to each other. Third, SQL gave us a way to ask questions, to query all the data they were storing. And the final ingredient? Tim Berners-Lee's World Wide Web. That created the open protocol that tied everything together. And remember that idealist philosophy of sharing? Well, it just exploded. Think about it. The foundational infrastructure of our digital world, the Linux operating system, which was created by Linus Torvalds, the Apache web server that runs most websites, the databases, so much of it was built by a global community of collaborators. For free, programming totally became a team sport. And that brings us to today, right now. After decades of humans painstakingly writing instructions, line by line, a totally new collaborator has just walked into the room. And that collaborator is artificial intelligence. And believe me, it is changing everything. But you know, this revolution wasn't just about AI, it was also about access. Programming isn't some Western monopoly anymore, it's a global dialect. You've got India training these armies of developers powering global infrastructure. You have African innovators who just leapfrogged desktops entirely and went straight to mobile. And the best part? Free tools like VS Code and GitHub mean that a teenager today with a decent internet connection can build things that are on par with what a Silicon Valley giant could do. That's huge. So that brings up a really big question, right? With these new AI tools, what is a developer's job actually becoming? I mean, we used to write every single line of code. Now, a lot of the time, we just describe our goal to an AI and it spits out the code for us. That line is getting really blurry. So, are we still programming or are we prompting? If you look at the big picture, this whole evolution is just a steady climb towards, well, doing less of the grunt work. We started by giving computers direct, step-by-step instructions. Then we moved up to just describing the outcomes we wanted with things like frameworks. And now we're learning to simply state our intention, our high-level goal, and we let our AI collaborators figure out the how. So when you think about it, from ancient clay tablets used for counting to the Antikythera's bronze gears to Turing's massive code-breaking machines and all the way to the quantum chips of tomorrow, this has always been a story of human imagination. It's this unending quest that we're on as a species, to turn a thought into logic, to turn that logic into an instruction, and to use that instruction to transform our world. And here's the most exciting part. This story isn't over, not by a long shot. In fact, it feels like it's just beginning. From Ada Lovelace sketching out an algorithm by candlelight to a kid in a classroom today training an AI model, this is our shared human history. And the next chapter, well, it's waiting for you to write it.